coolant circulation. The water pump pushes coolant through the engine where it absorbs heat. Hot coolant then flows to the radiator where air and the cooling fan release the heat. The thermostat regulates flow and the expansion tank handles pressure changes and is pulled through the pickup strainer by the oil pump. It then passes through the oil filter to remove dirt. Clean, pressurized oil flows to the crankshaft, pistons, and camshaft to reduce friction and heat. After lubrication, the oil returns back to the sump and the cycle repeats continuously while the engine runs.
Between manual and automatic cooling fans. A mechanical fan is driven by the engine belt, so it runs constantly and uses engine power. An electric fan works independently, turning on only when sensors detect heat, making it more efficient and fuel-saving.
Fuel injection system. Fuel is pumped from the tank, controlled by the ECU, and delivered through injectors into the engine cylinders. Precise fuel spraying improves combustion, increases power, and reduces fuel consumption and emissions.
Automatic transmission uses a torque converter, clutches, brakes, and planetary gears to change speed smoothly. The pump builds pressure, the clutches engage gears, and the output shaft delivers power without any manual shifting.
Brake pedal is pressed. The master cylinder pushes hydraulic fluid through the brake lines. This pressure reaches the brake caliper, forcing the hydraulic pistons outward. The pistons squeeze the brake pads against the rotor, creating friction. That friction slows down the wheel and safely stops the vehicle. AC compressor cycling means the compressor is switching on and off too quickly. The most common reason is low refrigerant, which causes pressure to drop and the system to shut off for safety. Overfilled gas, faulty pressure sensors, condenser airflow issues, or electrical problems can also cause rapid cycling. 12-volt battery through a fuse for protection. When the headlight or parking switch is turned on, the signal wire sends power to the tail lamp bulb. The red wire supplies power, and the black wire provides ground to complete the circuit. Once the circuit is complete, the tail lamp lights up safely and reliably. The radiator fan running all the time can be normal or a problem. In hot weather or heavy traffic, it helps keep the engine temperature under control. But if the fan runs even when the engine is cold, it can overcool the engine, waste fuel, and drain the battery.
Smell from the car AC usually comes from moisture and dirt. A moldy evaporator grows bacteria, a dirty cabin filter traps debris, a clogged drain pipe holds stagnant water, and a leaking heater core creates a sweet coolant smell. Clean and fix it early to keep the cabin fresh.
Engine oil is stored in the oil pan at the bottom. The oil pump pulls oil through the pickup strainer and sends it to the oil filter. After cleaning, pressurized oil flows through oil galleries to the crankshaft, connecting rod bearings, pistons, and camshaft. Oil cools and lubricates these parts, then flows back through return channels to the oil pan. This cycle continues as long as the engine is running.
Oil color tells us a lot about engine health. Golden oil means the oil is fresh and in good condition. Dark oil shows it's time for an oil change. Milky oil is dangerous because it indicates coolant mixing. Burnt oil points to overheating or engine wear and needs immediate attention.
Shaft and CV axle are often confused. In rear-wheel drive vehicles, the drive shaft transfers power from the transmission to the rear differential. In front-wheel drive vehicles, CV axles deliver power directly to the wheels while allowing steering and suspension movement. Different layouts, different jobs. S stands for Advanced Driver Assistance Systems, designed to make driving safer and easier. Lane Assist helps keep the car centered in its lane. Adaptive Cruise Control automatically adjusts speed to maintain a safe distance from traffic ahead. Auto emergency braking detects potential collisions, warns the driver, and applies brakes if needed. Compression ratio decides how much power and mileage an engine can deliver. A high compression ratio squeezes the air-fuel mixture more, producing higher heat, better efficiency and stronger performance. A low compression ratio creates less pressure, resulting in smoother operation but lower power and higher fuel consumption. That's why performance engines use higher compression, while economy engines use lower compression. Cooling systems use mechanical fans connected to the engine, simple but inefficient and always running. Modern cooling systems use electric fans controlled by sensors, operating only when needed. This improves cooling accuracy, reduces engine load, saves fuel, and maintains a more stable engine temperature under all driving conditions.
Starter motor works. Power flows from the battery through the fuse box to the ignition switch. When the key is turned, current activates the starter solenoid, which then supplies power to the starter motor, grounding the circuit and starting the engine to an automatic transmission. It uses three main parts: the pump, turbine, and stator. The pump moves transmission fluid, the turbine transfers power to the gearbox, and the stator increases torque for smooth vehicle acceleration. Alternator charging system wiring. When the ignition is turned on, current flows through the indicator wire to excite the alternator. The alternator then generates electricity. The voltage regulator controls output, and power is sent to charge the battery while maintaining proper system voltage. Automatic radiator cooling fan wiring. When engine temperature rises, the thermo switch senses hot coolant and sends a signal to the relay. The relay then supplies battery power to the cooling fan. Once the temperature drops, the switch opens and the fan turns off.
How an electronic throttle body works. The accelerator pedal sends two position signals to the ECU. The ECU compares these signals and controls the throttle motor. TPS sensors send feedback to ensure accurate throttle opening. This system improves safety, fuel efficiency, and engine control.
Working of a vehicle differential. The pinion gear drives the ring gear, which rotates the spider gears. These spider gears split torque between the axle shafts, allowing the wheels to rotate at different speeds while turning, ensuring smooth and stable vehicle movement. There are three main spark plug types: copper, platinum, and iridium. Copper plugs give strong sparks but wear fast. Platinum plugs last longer with better heat resistance. Iridium plugs offer the best performance, highest durability.
Diagram explains the difference between an open differential and a locked differential. An open differential allows wheels to rotate at different speeds during turns. A locked differential forces both wheels to rotate at the same speed, improving traction on slippery or off-road surfaces.
Internal combustion engine, the crankshaft converts piston motion into rotation. Pistons move inside cylinders, connected by connecting rods. Valves open and close using rocker arms and valve springs to control air and fuel flow. Spark plugs ignite the mixture, while the oil pump lubricates all moving parts for smooth, efficient operation. Ignition key is turned, the starter solenoid receives power and pushes the pinion gear forward. At the same time, high current flows to the starter motor. The motor spins rapidly, engaging the flywheel and cranking the engine. Once the engine starts, the solenoid disengages the gear, stopping the starter automatically.
Oil is stored in the oil pan and pumped by the oil pump through oil galleries. It lubricates the crankshaft, connecting rod bearings, pistons, camshaft, and valve train. This oil film reduces friction, carries away heat, and prevents metal-to-metal contact. After lubrication, oil drains back to the sump and the cycle repeats continuously.
Between a brake pedal switch and a brake pedal sensor. The switch works as on or off and directly turns on the brake lights. The sensor sends an analog signal to the ECU, helping with cruise control, safety systems, and smoother braking. Alternator charging system works. When the engine runs, the alternator produces electricity. The voltage regulator controls the output and charges the battery. Power is also supplied to vehicle accessories, and the warning light indicates charging problems.
Camera wiring system in a car. The camera gets power from the reverse light, so it activates only when reverse gear is engaged. The video signal travels through the yellow RCA cable to the display unit. Red wire supplies power, black wire provides ground, and the connection box ensures stable signal transmission for clear rear-view display.
Turn to start, a low current signal activates the starter relay. The relay then sends full battery power to the starter solenoid. The solenoid engages the starter gear with the flywheel and powers the starter motor. This cranks the engine until it starts running on its own.
Halogen gives basic light. HID shines brighter. LED is sharp and efficient, but laser headlights go the farthest, lighting the road like daylight. Ever wondered how a manual gearbox works? Power enters through the input shaft, moves to the counter shaft, and gears change the speed and torque. Lower gears give more power, higher gears give more speed. The synchronizer makes smooth shifting, and reverse gear flips the direction, explains a manual clutch assembly. The flywheel is fixed to the engine and rotates continuously. The clutch plate sits between the flywheel and pressure plate. When engaged, engine power transfers smoothly to the gearbox.
And inductive sensors. The Hall effect sensor needs power and produces a clean, digital square wave signal, even at very low speeds. In contrast, the inductive sensor is self-powered and generates an analog AC signal that increases with engine speed.
Our engine cooling system controls engine temperature. The water pump circulates coolant through the engine to absorb heat. When the engine warms up, the thermostat opens and sends hot coolant to the radiator. Air passing through the radiator cools the fluid, which then returns to the engine. Proper cooling prevents overheating and engine damage.
Universal joint, or U-joint, transfers power between two drive shafts even when they are at an angle. In a straight position, power flows smoothly. When the shaft moves up or down, the U-joint allows angular movement without breaking power flow. Proper lubrication is important because worn U-joints can cause vibration, noise, and driveline damage.
Chain both keep the crankshaft and camshaft in sync. A timing belt is made of rubber, runs quieter, and costs less, but needs regular replacement. A timing chain is made of steel, lasts much longer, but is noisier and more expensive. Both do the same job, but with different durability and maintenance in 4 steps. First is intake, where the air-fuel mixture enters the cylinder. Second is compression, where the piston compresses the mixture. Third is power, when combustion pushes the piston down and produces energy. Finally, the exhaust stroke pushes burnt gases out. Fuel injector becomes dirty, fuel spray turns uneven instead of a fine mist. This causes poor combustion inside the cylinder. One cylinder runs lean or rich, creating vibration, misfire, power loss, and overheating. Over time, this imbalance can lead to piston damage, cylinder wear, and serious mechanical failure if injectors are not cleaned or replaced on time. Needed fuel starts problems from the fuel tank itself. Dirt and water clog the fuel filter, reduce fuel flow, and damage injectors. Poor spray causes incomplete combustion.
Diagram shows a common rail fuel injection system. The high-pressure pump sends fuel to the common rail, where pressure is controlled and stored. From there, fuel flows through high-pressure lines to each injector, delivering precise fuel into every cylinder for better performance, efficiency, and lower emissions.
Power steering uses an engine-driven pump to pressurize steering fluid. This pressure is controlled by a valve and sent to the hydraulic cylinder, which helps move the steering rack. The system reduces driver effort, making the steering wheel easier and smoother to turn. Uses a torque sensor to detect steering effort and sends signals to the EPS control unit. The ECU commands an electric motor to assist steering based on vehicle speed. Low speed gives light steering. High speed gives firm control, improving safety and fuel efficiency.
Alternator converts engine rotation into electrical power. It generates AC voltage, then diodes convert it into DC. The voltage regulator controls output between 13.5 to 14.5 volts, charging the battery and powering all electrical systems while the engine is running. The speed sensor monitors how fast each wheel rotates and sends digital signals to the ABS and ECU. If the sensor or magnetic ring fails, ABS may activate incorrectly. Speedometer can stop working, and braking becomes unsafe. A faulty wheel speed sensor directly affects vehicle stability and safety.
The DC motor and scissor-type regulator to move the window glass up and down. When the switch is pressed, electrical signals drive the motor, rotating gears that move the regulator arms smoothly. This system provides convenience, comfort, and reliable window control.
For engine overheating, first check the thermostat. If it's stuck, coolant can't flow. If the radiator fan isn't working, heat won't escape. Airlock in the cooling system makes the engine run hot and the heater weak. Fix these early to avoid serious engine damage.
Shows how hydraulic power steering works. When the driver turns the steering wheel, the pump sends pressurized fluid through the high-pressure hose. This fluid moves the piston inside the steering rack, reducing steering effort. The fluid then returns to the reservoir, keeping steering smooth and controlled.
Keeps the engine safe from overheating. Coolant absorbs heat from the engine and flows to the radiator. Air passing through the radiator cools it down. The water pump circulates coolant back to the engine. Common problems include coolant leaks, rust, a failed water pump, or a stuck thermostat.
Stroke engine works in 4 steps. During intake, the air-fuel mixture enters the cylinder. In compression, the piston moves up and compresses the mixture. In the power stroke, combustion pushes the piston down and produces power. Finally, in exhaust, burnt gases are pushed out, completing one engine cycle.
Shows how the fuel system delivers fuel to the engine. Fuel flows from the tank through the fuel pump and fuel filter. The high-pressure pump sends fuel to the fuel rail. The ECU controls the injectors, spraying precise fuel amounts into the engine for efficient combustion and smooth performance.
How a conventional ignition system works. When the ignition switch is turned on, current flows from the battery to the ignition coil. The distributor cam opens and closes the contact points, creating high voltage. The rotor arm directs this voltage to the correct spark plug, igniting the air-fuel mixture in each cylinder at the right time.
Explains how electric power steering works. When the driver turns the steering wheel, the torque sensor detects the input force. This signal is sent to the electric motor, which adds assistance through the rack and pinion. The result is lighter steering, better control, and improved driving comfort.
Shows how a hydraulic clutch system works. When the clutch pedal is pressed, hydraulic fluid moves from the master cylinder to the slave cylinder. This action pushes the release bearing, separating the clutch disc from the flywheel. As a result, engine power is disconnected from the transmission.
Shows how engine lubrication works. Oil is drawn from the oil pan by the oil pump and sent through the oil filter. Clean oil flows through internal passages to the crankshaft, connecting rods, and cylinder head. Proper oil circulation reduces friction, controls heat, and protects engine parts from wear.
Engine cycle. First is intake, where the intake valve opens and air-fuel enters the cylinder. Next is compression. Both valves close and the mixture is compressed. Then power stroke. The spark plug ignites the mixture and pushes the piston down. Finally, exhaust stroke. The exhaust valve opens and burnt gases leave the cylinder.